In this video, I'm going to talk about how we can apply systems of equations to many real-world situations and many word problems as well. So some examples of word problems we can apply systems of equations to include how many coins of each value, perimeter and area type problems, how many of something are there, how much did they invest, which is the better deal, basic addition and subtraction pairs, as well as age problems. Now there are many more examples than just these, but for these examples, I'll be going over specific problems that apply to each one of these examples. So the steps on how to solve one of these, systems of equations word problems. So the first thing we need to do is to define our variables. Now that can be something as simple as just calling one variable x, one variable y. But what I like to do and what I would recommend as for all of you to do would be to call them something that's a little bit more memorable so you don't mix up your variables. Our next step then is going to be to look for common types of equations, so total number, total value, etc. Now this is something that is going to make a lot more sense when I actually go through an example. And then our next step is just to make our equations, and then our step after that is of course just to solve these equations. Now if you're not super proficient with systems of equations and solving systems of equations, I would recommend you watch my previous video on how to solve systems of equations. Otherwise, this is probably going to be pretty difficult for a lot of you if you are not super familiar or somewhat proficient at least at solving systems of equations. Now let's go through some examples. So our first example here is an example that's based on the how many coins of each value type of problem. So this is a very, very common type of problem to see in both the SAT and ACT. So Dan has 18 quarters and nickels. He puts them into a machine that only displays the total value of his coins, which comes out at $2.90. How many of each coin does Dan have? So in this problem, we're trying to see, okay, how many quarters and how many nickels does Dan have? So our steps here, now our first step, right, is to define our variables. So let's define our variables. I'm going to say, instead of, just using the x and y like we kind of talked about, I'm going to say that Q stands for quarters, our number of quarters. So number of quarters. And then I'm going to say that N stands for our number of nickels. So now we have defined our variables, we can kind of move on and just start solving our equations here, or solving for our equations. So Dan has 18 quarters of nickels. Our next step here is to look for common types of equations. So this is actually an example of a total number problem, right? We have a total of 18 quarters of nickels. So I know that the total number of quarters, Q, plus the total number of nickels, N, is equal to 18. And then I also know that the total value of the coins comes out at $2.90. Now this is a total of 290 cents. So I can say that the total value in cents of all the quarters is going to be 25 cents for each quarter times the number of quarters, right? And that's the total value from all of the quarters. And then I can do plus 5 cents times the number of nickels, and I know that equals a total of 290 cents. So now that I've done that, I'm going to see, okay, how can I solve this problem? Well, looking at this, I think the best way to solve this might be elimination. Substitution would work totally fine as well, but I'm going to do elimination here. I'm going to multiply this first equation by 5. And that way I'll end up with a 5n that I can cancel out. So 5 times q, 5q. 5 times n plus 5n. And then 5 times 18 is equal to 90. And then what I'll do is I'll subtract that second equation from the first equation. 25q minus 5q is just equal to 20q. And then 5n minus 5n is just equal to 0, so 20q plus 0. And then 290 minus 90 is just equal to 200. So then I have 20q is equal to 200. So 20q is equal to 200. I'll divide both sides by 20, and I'll get q is equal to 10. Now that I have q is equal to 10, I can just plug it into either of these equations to solve for n. So what I'm going to do here, I have q plus n is equal to 18, so I know that 10 plus n is equal to 18. I'll subtract 10 from both sides, and I will get n is equal to 8. So I should have 8 nickels and 10 quarters. So now I'm going to plug it into that second equation just to make sure I've done it right. So 25 times q, that's 25 times 10. plus 5 times n, so that's 5 times 8, is equal to 290. So let's just multiply this through. So 25 times 10 is 250. 5 times 8 is 40. And that is equal to 290. So I just proved that this is the answer. 290 is equal to 290. So I have 10 quarters and 8 nickels. And that's how we solve this problem. The next type of problem we're going to work on here is the perimeter and area type problem. Now this is a very, very common type of problem to see again in both the SAT and ACT. So this one's going to require a little bit of our basic algebra skills just to start off with. So the length of a plot of land is 150 feet longer than the width. Now, like I did on that previous problem, I'm going to define my variables here just to start off with. So first of all, I'm going to say length, and I'll just write it right above here. I'm going to call that L. And then I'm going to say my width is just going to be W. So length and width. So now that I've defined length and width here, I need to basically make my first equation. So my first equation here, so the length of a plot of land is 150 feet longer than the width. Well, that means I know the length of the plot of land is equal to the width plus 150 feet, right? Plus 150, because the length is equal to the width plus 150. Now, the perimeter of the plot of land is 700 feet. So let's look at just a rectangle here. And if I look at a rectangle, I can see that, okay, I have one length here, another length here, one width here, another width here. So I know that 2 times the length, the perimeter is equal to 2 times the length, right? Because we have 2 lengths, plus 2 times the width, because we have 2 widths. Again, the perimeter is just the distance all the way around the outside of that rectangle. So if I know it's 2L plus 2W, and I'm also given in this problem here that the perimeter is 700, I'm going to say that 2L plus 2W is equal to 700. Now, in this first equation, I've already solved for L. So I'm just going to do substitution for this problem. I'm going to use substitution here just because I can substitute in that W plus 150 for the L right here. So 2 times W plus 150, and then plus 2 times the width. So I'll just write 2. I didn't really need to make the parentheses there, but that's 2 times W. And I'll erase that really quickly and draw that a little bit neater there. So 2 times the width, and then that's equal to 700. So let's just multiply out here. So 2 times W is 2W, and that's really important. We remember to distribute properly here, so then we do get 2 times 150, so that's plus 300, and then plus 2 times W, which again is just 2W, and that's equal to 700. So the first thing I'll do is I'll just combine my like terms, both those 2 W's, and I get 4W plus 300 is equal to 700. And then I'll just move right up here. And then I'll subtract 300 from both sides, and I'll get 4W is equal to 400. 700 minus 300 is 400. And then I'll divide both sides by 4 here. And I'll get W is equal to 100. So now that I have the width is equal to 100, let's solve for the length. Well, the first thing I'm going to do is just plug it into that first equation. And hopefully that'll solve for the length. It should. But then I want to make sure that it's 100% the right answer by plugging both the new values into that second equation. So length, or length will be the only new value here, but I just want to make sure by plugging both the values I have into the new equation. So the length is equal to the width plus 150. The width here we got 100, so the length is equal to 100 plus 150. The length has to be equal to 250. Now let's make sure by plugging it into the second equation, the 2L plus 2W is equal to 700. So 2 times length, which is 250, plus 2 times the width, which should be 100. This all should be equal to 700. So 2 times 250, that's 500. 2 times 100, that is 200. And yes, that is going to be equal to 700. So 700 is equal to 700. That is the right answer. So my answers here are the width is 100, the length is 250. And that's how we do the perimeter and area problem. Now this, again, is super common, and I would say super common in the SAT specifically as well. So if you're taking the SAT, really kind of memorize how to do this problem and how to approach this problem as well. So let's move on to our how many of something are there example problem. So in this problem, there are 68 students on Miss Franklin's 6th grade science camp trip. They are all staying in tents that hold either 3 or 5 people, depending on the type of tent. And there are a total of 16 tents. How many tents of each type are there? Well, I'm going to say that for the 3-person tents, I'm going to call that S for the smaller tent. The smaller tent has 3 people. So the smaller tent is the 3-person tent. And then the larger tent is the 5-person tent. So now let's make our equations. So let's look for the common types of equations here. Now I can see a total equation right off the bat. There are a total of 16 tents. So I know that the total number of smaller tents plus the total number of larger tents is equal to 16. And then let's look for our total number of people here is 68. So I know that if there are 3 people in each smaller tent, the total number of people staying in smaller tents is equal to 3 people times S, times the number of smaller tents. And then if there are 5 people staying in each larger tent, then I know it's 5 people times the number of larger tents. And then that should be equal to a total of 68 students. So for this problem, I can use either elimination or substitution here. I think I'll use elimination though, and I'll just multiply both sides of this first equation by 3. So 3 times S is going to be 3S. And then 3 times L is going to be plus 3L. And then 3 times 16 is going to be equal to 48. And then I'll just subtract that second equation from the first equation here, 3S minus 3S. That's just equal to 0. And then 5L minus 3L is plus 2L. And then 68 minus 48 is equal to 20. So then 2L is equal to 20. Divide both sides by 2, I get L is equal to 10. So now that I have L is equal to 10, let's plug it into this equation here. This S plus L is equal to 16, and let's find how many smaller tents there are. So I know that S plus L, now L in this case is 10, is equal to 16. We subtract 10 from both sides here, we get S is equal to 6. So there should be 10 larger tents and 6 smaller tents. But let's make sure by plugging both of these values into that second equation, that 3S plus 5L is equal to 68. So 3 times S is 3 times 6, plus 5L, which is 5 times 10, and that should be equal to 68. So that's 18 plus 50 is equal to 68, and perfect. We end up with 68 is equal to 68. So the total number of larger tents, the total number of 5-person tents is 10, the total number of smaller tents, or the 3-person tents, is 6. So this next problem is in the category of how much did they invest, and this is one of the most difficult problems I'll be going over in this video. So it starts off with Brett recently got a pay rise, so he has $5,000 to invest. He put some money in a savings account where he earned a 2% yearly return, and some money in an investment account where he earned a 5% yearly return. At the end of the year, he had $5,155.50. How much did he invest in each account? So just to start off with, let's go over just our percentages and our returns kind of. So remember, if we're getting a 2% yearly return, then we're multiplying our original value by 1.02 because it's 1 for the original value plus 2%. And then for the 5% return, it's just going to be 1.05. And my variables here I'm going to define, I'm going to say for the amount of money in the savings account is S, the amount of money in the investment account is I. Or you know what, I'll go S for smaller and then L for larger. So the 5% is the larger return, the 2% is the smaller return. So we know that the total amount of money we originally put in, we're looking for how much money did he invest originally in each account. So I know that the total is 5,000. So my total equation here is just S plus L is equal to 5,000. And it's yet another example of just a very, kind of easier total equation. We've been seeing these in all these examples we've been going over. So then I know that at the end of the year, he had $5,155.50. So I know that the return for the smaller one, the smaller account, the savings account, is 1.02 times the amount we originally put in the smaller account. So that's the total return from the smaller account. And then plus for the larger account, 1.05, right? That's our return from the times the amount of money we originally put into the larger account. And I know that whatever that is over a year is going to be equal to $5,155.50, or just 0.5. So now I have my choices here on what I want to use to solve for this. And I think also here I'm going to use elimination. So I am going to multiply, or you know what, here I'm going to use substitution just because I'm not sure I want to multiply everything by, actually I'm being very indecisive here, but yeah, I am going to use elimination here because what I can do here is I can just multiply everything by 1.02 and cancel out that 1.02s. So let's just do this, and we have, and I'm going to erase really quickly this little line I put here. So we have 1.02 times s, that's 1.02s, and that's why we're doing this, so that other 1.02s cancels out. And then 1.02 times L is plus 1.02L. And then 5,000 times 1.02, do 5,000 times 1.02, that's going to be equal just to 5,100. So that's equal to 5,100. And then let's just do our elimination there. So 1.02s minus 1.02s is going to be equal to 0. And then 1.05L minus 1.02L is just going to be equal to 0.03L. And then 5,155.5 minus 5,100 is just going to be equal to 55.5. Then let's divide both sides by 0.03. So, of course, 0.03L divided by 0.03 is just going to be equal to L. That's supposed to be an arrow there. And then that's equal to 55.5 divided by divided by 0.03. And if I do that, I get 1,850. So in my 5% account, I'm getting $1,850. Now, let's plug this into the first equation here. This s plus L is equal to 5,000 to solve for s. So 1,000, or I'll just actually start with the s plus 1,850 is equal to 5,000. And then subtract 1,850 from both sides here. So 5,000 minus 1,850 is going to be equal to 3,150. So the amount of money in the smaller account, and the 2% account is 3,150. And then now that I found those two here, the smaller and the larger, I'm going to plug those into the second equation we had here, which was this equation right here. Just make sure all the numbers work out. So 1.02 times s, which is 3,150, plus 1.05 times L, which is 1,850. And I should get 50 or 51, 55, 50. So 1.02 times 3,150, I get 3,213. And then 1.05 times 1,850, I get plus 1942.5. And then if I add those, I get 5155.5, which is what I should get. And that's how we do this problem. So just remember, for this equation, I think the most important things to remember here is just, make that simple total equation, and then move on here and remember that the value you're putting in for the second equation, right? It's not the same as 5,000 here. It's the new value for the value of, or the amount of money that you have after 1 year in the investment accounts. And then of course, remember that a 2% yearly return, you multiply by 1.02, and then for a 5% yearly return, 1.05. And then if you have any more questions on this problem, feel free to just comment or email me. and hopefully I can clear anything up that you're maybe struggling with just a little bit. So this next problem is a which is the better deal type problem. Now this is a very, very common type of problem that you'll see primarily in the SAT, but also in the ACT as well. So the problem goes, Phoebe wants to rent an inflatable slide for her sister's birthday party. She called two businesses. Alex's slide company gave her a price of $20 an hour plus a $100 flat fee. And then Barbara's inflatable slides gave her a price of $15 an hour plus a $165 flat fee. At what length of time and hours are the overall prices for the two companies the same? So this is technically a systems of equations problem. So I know that the price, and I'm going to call it the price for Alex's slide company, or I'll just give it a variable of p. The price for Alex's slide company is going to be equal to $20 an hour. So $20 times how many hours there are plus a $100 flat fee. And then the price for Barbara's inflatable slide company is $15 an hour. So $15 times how many hours Phoebe rents it for, plus a $165 flat fee. And since I'm trying to find at what length of time are the overall prices for the two companies the same, I can equate the two P's to be equal to each other, right? Because I'm trying to find when the prices are the same. So this is a skill that you really, really want to, understand and kind of, keep in the back of your mind, because this is something you'll see a lot in the SAT and ACT. Basically, every single SAT test I've taken, especially, I've seen one of these where the prices for something are equated, and we have to solve a systems of equations just like this, or system of equations just like this. So we have the two P's here being the same. So what that means is I can equate this 20H plus 100 and this 15H plus 165. So I'm going to say that 20H plus 100 is equal to 15H plus 165. And once we solve for the hours, we can solve for the price. So let's subtract 15H from both sides here, and I'm going to get 5H plus 100 is equal just to 65. And then I'll subtract, that shouldn't just be 65. Sorry, that should stay as a 165. I'm jumping steps here. So that is equal to 165. And then we'll subtract 100 from both sides, and I'll get 5H is equal to 65. And now what I can do is I can divide both sides by 5 here, and I get H is equal to 13. So it should be 13 hours when the prices are the same. So let's just plug my number in and make sure that the prices come out the same. So the price for Alex's is going to be price is equal to 20 times the number of hours. So the number of hours is 13 plus 100. So that's equal to 260 plus 100, and that is equal to 360 total dollars. And then for Barbara's slide company, it's going to be, the price is going to be equal to 15 times 13 plus 165. So 15 times 13 is going to be equal to 195. And then the price is going to be equal to 195 plus 165. And 195 plus 165 is equal to 360. So I know that at 13 hours, the prices for the two companies are going to be the same, and the price for the two companies is going to be $360. So again, that problem, if you know how to approach a problem like this, it's quite easy and it doesn't take much time. You can see I really didn't have to write a lot here. I probably wrote more than I needed to. But if you don't know how to approach a problem like this, it is going to be a lot more difficult. So I would always keep this in mind, how we could just equate these two P's. And that way we can equate the 20H plus 100, and then of course the 15H plus 165. So this next problem here is actually quite easy if you know how to approach a problem like this. And this type of problem is more common in the ACT than SAT for sure. I don't see too many problems like this in the SAT, but it could always appear. So if you're taking the SAT, always prepare for this type of problem as well. So the first thing we get in this problem is the sum of two numbers is 235. So what that means is that, we got to remember that the sum means addition. So that means the smaller number plus the larger number is equal to 235. And then the difference between the larger and the smaller number is 57. So that means the larger number minus the smaller number is equal to 57. So what are the values of the larger and smaller numbers? For this problem here, I think I'm going to use substitution. So from this first equation here, I'm going to subtract L from both sides. So I'll get S is equal to 235 minus L. And then what I can do is just substitute in this 235 minus L in for that S right there. And it's really important that I pay attention to where the negative is in this equation as well. So I have L minus 235 minus L, and that's equal to 57. Now remember, we can treat this minus sign here kind of as a multiplied by -1. It's the same thing. We just kind of make that 1 invisible. So -1 times 235 is just minus 235. But then -1 times negative L times minus L is going to be plus L. And that's equal to 57. So the first thing I'm going to do here, let's combine our two L's here. So L plus L is 2L. And then I'm going to add 235 to both sides. So 57 plus 235 is equal to 292. And then I'll just divide both sides by 2 here, and I'll get L is equal to 146. So L is equal to 146. Now let's plug that 146 into the first equation here to find the smaller number. So the smaller number plus the larger number, which is 146, is equal to 235. And then we'll subtract 146 from both sides of this, and we will get the smaller number. The smaller number is equal to 89. And then let's just plug both into the second equation. The L minus S is equal to 57. So 146 minus 89 is equal to 57. Now 146 minus 89 is equal to 57. So 57 is equal to 57. We checked it and we know that this is right. So our larger number is 146, our smaller number is 89. And as you can see, just like that last problem we did, if you know how to approach a problem like this, it's really not too bad. Now, the only thing that'll help you a lot with this is, you can memorize kind of the steps I took to do this problem, and that'll help you. That'll help you, no doubt. But what will really help you is just practicing and practicing problems like this. So I really recommend going off on your own and just practicing problems like this. So unlike the last two problems we just did, this problem is actually a little bit more difficult, and it is actually pretty hard to understand. So if you don't understand it first time, I would recommend just watching this video back and just looking at it again, because it can be kind of hard to wrap your head around. So in this problem, we have Alex is 7 years older than Maddie, and then in 5 years, Alex will be twice as old as Maddie. And what we're looking for is how old is Alex and how old is Maddie, and that would be currently. So the first equation here, or first I need to define my variables. So I'm going to say that A is how old Alex is, and M is how old Maddie is. So Alex is 7 years older than Maddie. So Alex's age is equal to Maddie's age plus 7. That's our first equation, and that equation is very similar to a lot of equations we've been doing previously in this video. Now the second equation is where it gets kind of difficult. So in 5 years, Alex will be twice as old as Maddie. So in 5 years, Alex's age is Alex's current age plus 5 years. And then in 5 years, Maddie's age is going to be her age plus 5. Now in 5 years, Alex's age is twice that of Maddie's. So I'm just going to do Alex's age plus 5, or Alex's age in 5 years, is twice that of Maddie's age plus 5, or Maddie's age in 5 years. So now what I'm going to do is I'm going to multiply through on the right side here. So I'm going to get A plus 5 is equal to 2M plus 10. Then I'll just do some simple substitution here, and I'm going to substitute in this M plus 7 for the A right here. So I'm going to get M plus 7 plus 5 is equal to 2M plus 10. Now the 7 and 5 will combine to 12. And the first thing I'm going to do here is I'm going to subtract M from both sides. So I'm going to get 12 is equal to m plus 10. Then I'll subtract 10 from both sides, and I'll get 2 is equal to Maddie's age. So let's plug Maddie's age back into that first equation. Alex's age is equal to m plus 7, so Alex's age is equal to 2 plus 7. So Alex's age is equal to 9. So that's Alex's age, that's Maddie's age. Now let's make sure by plugging it into that second equation. So 9 plus 5, Alex's age plus 5, is equal, and I'm just going to use this one right here, the expanded out version of that equation, is equal to 2 times Maddie's age, so 2 times 2 plus 10. And I'll get 14 is equal to 4 plus 10, so 14 is equal to 14. And then just to prove to you that this does actually work, so let's think about it. So Alex's age is equal to 9, Maddie's is equal to 2. So in 5 years, Alex is going to be 14. And then in 5 years, Maddie is going to be 7, right? 9 plus 5 is equal to 14. 2 plus 5 is equal to 7. So from that, we can kind of just see, right? Alex's age is twice that of Maddie's. Maddie's age times 2 is 14. Okay, so if you have any questions, feel free to email me or ask them in the comments, and I'll do my best to reply to those as quickly as possible. Also, in the description will be my email and link for one-on-one tutoring. And then thank you for watching, and again, let me know if you have any questions. I will do my best to reply to those as quickly as possible.